Sometimes AI is Einstein, other times a goldfish. Why? Because it's not really thinking, it's just vibe talking. What does that even mean? Let's crack open the transformer engine, the brain behind ChatGPT, Sora, robotics, and basically every smart AI out there. We'll nail down, attention, the ultimate word social networking party, neural network, the deep processing factory where ideas get built. Word embeddings, tags that give words meaning. Watch till the end and you'll be fully prepped for Andrew Karpathy's videos. Or as I like to call him with respect, Karpathy Sensei. So hop on board, we're taking off into the brain of AI. Act 1. The black box. Big picture first. You say, I adore you. GPT black box wraps up, boom, spits out a word. Then it glues to the sentence, runs the whole thing again, then boom, sweet. Then again, word by word like squeezing toothpaste. But here's the killer. For spitting every new word, it copies the entire combo and rewrites the essay. Each time. That workload is insane, and that's just the appetizer. Act 2. Words to numbers. Okay, inside the box, the pipeline goes like this. Tokenizer, embedding, layer norm, attention, layer norm, MLP, output. Alien words, relax, I'll break it down. Step 1. Tokenizer. Take the sentence, I adore you. It first becomes a chain of digits, each one a token. But here's the catch. One word is not necessarily one token. Example, strawberry gets chopped into 3 tokens in GPT-4o. Now the meme makes sense. Why can't AI count R's in strawberry? Because it never sees letters. It only sees those numbers. Also vocab size, huge. GPT-2, for example, uses around 50,000 unique tokens, numbered from 0 to 50,000. For easy to understand, in this video I'll use words instead of tokens. Congrats! You now officially speak the model's language. Act 3. Word embeddings. Tokens alone, not that useful. The model's real power is knowing what they mean. Here's how. It builds a gigantic semantic map. Every word has a coordinates on it. Apples? Boom, that's a vector. In GPT-3, each vector has about 12,000 dimensions. Of course, here, we shrink it into 3D so humans can see it clearly. And here's the magic. Words that are besties end up close on the map. Apples is literally hanging with oranges, tomatoes, sugar. But houses is chilling way off in the real estate land with homes, palace, buildings. These vectors can even do math. Apples minus eat equals juice minus drink. But wait, position matters too. The model also encodes where the word sits in the sentence, so it can tell the difference between you ate the tiger or the tiger ate you. Quick wrap up. LLMs don't just memorize words. They build a map of meaning where the distances, who's close, who's far, matters way more than the raw numbers. And this whole map learned during training. Act 4. Attention. Context is the king. But here's the twist. Word meaning shift with context. Tower alone, just a tower. At Eiffel, boom, romance vibes in Paris. At Lego, suddenly it shrinks into a toy. So how do we capture context? Enter the most fun part. Attention, the ultimate word social networking party. Take this sentence. I visit the Eiffel Tower on a sunny day. We want the system to know Eiffel describes tower, sunny describes day, not Eiffel day or sunny tower. Here's how the party works. Every word shows up with 3 cars. Query, what am I looking for? Key, who am I? Value, what value can I give? What vibe can I share? All 3 are vectors. So Tower's Q says, I'm looking for something to define me. It checks all words key to see who's the match, including itself. Apple's key says, I'm a noun, usually paired with tower. Sunny's key says, I'm an adjective for weather. And the result is tower and apple, strong match. Tower and sunny, nah, nobody says sunny tower. So tower grabs Apple's V in big dose, say 0.9, and only a tiny sprinkle from sunny's V, say 0.01. Congrats, you've got yourself a romantic Eiffel Tower. Now the math bit. Matching Q and K is done by taking their dot product. Big dot product means strong relation. Small dot product means weak relation. And this number becomes a weight. Then we run it through softmax function to scale all weights into nice clean probabilities. 0 to 1. That number decides how much dose of V a word receives. You may ask, where do QKV come from? They are computed from weight matrices. WQ, WK, WV. And these matrices are learned during training, just like those word embeddings. and this matching plus vibe sharing happens between every pair of words, including themselves, and that's one round, one head. In GPT-3, this happens 96 times. Why? Act 5. Multi-head attention. 96 head, each head sees context from a different angle. Take this phrase. Lego Eiffel Tower. Head 1 is a name freak. It thinks Eiffel is the key modifier. Head 2 is a scale nerd. Wait, it's a Lego, it's a mini version. With 96 heads in GPT-3, some care about appearance, some about history, some about random trivia you didn't even think of. Together, they build a 4K, ultra-dimensional 360 profile of tower. One head alone just knows it's an iron tower. Multi-heads together know it's tall, romantic, perfect proposal spot, 2-hour line, great crepes nearby. Congrats, you made it here. You already get how the model vibes words together, how it nails subtle context and emotions. Act 6. The factory MLP. After the attention party, each word's vector is packed with context, but still raw. Next stop, the MLT factory, multi-layer perceptron. It grinds, mixes, and refines the info through 2 linear layers with a non-linear twist. The secret sauce that lets the model capture complex curvy relationships instead of boring straight lines. This stage runs on billions of parameters. Finally, and the residual connection merge the upgrade with the original, keeping the strong base and stacking fresh insights on top. Act 8, the final boss, output. Time for the output layer to answer, what's the next word? By now, every token's context vector contains a lot of meanings, especially the last one. The final context vector of I adore you may contain feelings of sweet, playful, and teasing. First, we project this vector across all 50 tokens in the vocab to get raw scores, logits. The closer a token sits to the vibe, the higher its score. Second, we use softmax function to turn those scores into clean probabilities. Third, pick one, play it safe, choose the top token, Want some flavor? Add randomness. Maybe it picks haha, boom, screen lights up. Then the new word joins the loop and the cycle begins again. Act 9. Layer norm. By the way, I skipped something important on the way here. Layer norm. Let's check it out too. And normalize each vector so the numbers don't go wild. Too big, drowns everything out. Too small, gets ignored. Layer norm evens the volume like a moderator in a meeting. Same level folks, no yelling, no whispering. Result. Every piece of info enters the next stage fair and square, and we do it twice, before attention and before the MLP to make it stable. Act 10. Now let's also talk about its training. The goal of training is to learn all those parameters. Word embeddings, WKQV, weights for MLP, and others. At first, the model's a total newbie. Example, feed it to be or not to be, that's the question. Mask word one by one and ask it to guess. Early on, it blurts out nonsense. To be or not be, that's the choice. Then comes the grind. First, compute the loss, which indicates how wrong it was. Then use gradient descent to adjust weights. Try again, fail, and repeat. Millions, billions of iterations later, it finally nails it. To be or not to be, that's the question. That relentless cycle of fail, tweak, retry is how the model learns its wisdom. Congrats! You've just walked the full transformer journey. Tokenizer, embeddings, attention, MLP, output, training. Now you know why it vibes, why it lies, and how it dances with the vectors to predict the next word. Next stop, dive into the full course with Andre Sensei. Thanks for watching. If this finally clicked, smash like, drop a comment, share it with a friend who's still lost in the math fog, and don't forget to subscribe for more deep dive brain snacks. This is Taijin, turning hardcore tech into sweet little desserts. See you next time!